As I always start off my sensation and perception class with this introduction to sensation and perception. And I like to start off distinguishing between, I like to start out with distinguishing sensation from perception. He has gone away from this in the textbook. This is the first edition where he says it's not really as important anymore. Usually what you're reading in the field and in the textbook is about perception itself, because most of what we know about sensation we've known for at least decades, if not longer, what's happening at the sensory organs. But I do like to distinguish it. I think it's important to distinguish that sensation is what's happening at the sensory organs, that changing of the sensory information, the environmental information, into something that the brain can understand. And perception really happens at a later place. And especially if we're thinking about conscious perception, which often when we're talking about perception, we mean something that's conscious to us, right? In fact, sometimes we use those a little bit interchangeably in the field, where we have the brain's organization and interpretation of those sensations, giving meaning to those sensations. I usually give this example. I usually give a couple of examples here. So one is that, so my brother is schizophrenic, and when we discuss our perception of something that happened in the world, some event, of course we are two different people sitting in two different places. What's happening at our sensory organs is pretty similar to each other, even though I do have some bad eyesight and some damage to my hearing, and he might not have quite that going on. But what happens when we're talking about what we're perceiving, he perceives a really different world than me. All of that information has gone through those subcortical structures, and the how his brain is different means that he interprets the world very differently, so giving meaning to those sensations. There's one more example that I like to give, is this, if you can just kind of pull your finger back and forth across your arm. So just rub your arm a little bit with your finger, just maybe kind of slowly, and think about how that feels. And in this context, that just feels like someone moving their finger back and forth across your arm. And that's the sensation. And in each of these examples I'm about to give you, that's going to be the same sensation. It's going to be the slight change in firing in those mechanoreceptors underneath the skin. Well, if we imagine, so we're sitting next to someone we have romantic interest in, or with our lover, and we're watching a scary movie, and our lover rubs his or her finger up and down our arm, that's going to be a really different perception of that sensation than if we are going through the airport and the TSA agent is doing that same rubbing up and down our arm. And that's going to be a different perception. We're going to perceive that really differently than if we're in a dark alley walking by ourselves and suddenly somebody starts rubbing up and down our arm, some stranger. That's going to cause a lot of anxiety, and our perception of that is completely different as we kind of freak out. So the sensations, again, are the same, and our perception of those sensations are very different depending on the context and depending on how that processing is going through the brain. So I have my green questions, which are going to be in my PowerPoints and in class throughout the semester, of where I want you to really stop and think and answer these to some extent to yourself. So think about what you perceive right now. In class, when we go to face-to-face classes, I usually spend a few seconds silently. So I'm going to give you a few seconds. And usually what I get from the class is a lot of visual information, some auditory. Usually there's some white noise in the background. Some people sometimes are sucking on a mint or gum or something. Other people might smell something near them. Some people talk about something touching their skin or something. But we stay a lot in the visual and auditory world. But those other sensations and those other perceptions are there. So throughout the semester, I can't remember now how often I remind you. I know I come back to this when we move from vision to sound, but try to bring awareness to your perception. to some extent you want to apply the concepts, but some of this is just, I find it also very kind of meditative and helpful to just be aware of my perception. And I used to use the example that he gives in the textbook, which if you want to go to the textbook and just kind of read at the beginning of this chapter about the idea of putting together some artificial being that is able to navigate from point A to point B, to perceive the world enough to navigate without running into obstacles. I usually ask students at the beginning of the class to kind of think through how they would do that and what that machine would need. I use this picture to kind of address the complexity of perception. So if we start over actually on the right with the ones and zeros, back in the 50s when those computers first came out, we thought we were going to have some amazing kind of robots pretty quickly. That quickly became the kind of the science fiction of the time. But that's really difficult, and that is, we can do a lot with computers as far as calculating and processing. And then up at the top there, we can even get one of those computerized chess games to beat some of the grandmasters of chess. Or sometimes that's how they practice. And then on the left bottom there, that is a scientist who created that robot who can, it almost seems like a who, that can process language and new sentences and respond back with novel sentences. So that's really impressive to someone who comes from a language background, that generativity of language is there in that robot. But none of these, we can do all of that, and we've gotten all of that. Clearly, some of that is decades and decades old, but perception is more complex. I include this slide maybe just to show you what a nerd I am, but then to also to reiterate that so once we got those computers, you can see in the top examples in Lost in Space, that robot that says "Danger, danger, Will Robinson," and the robot Maid in the Jetsons. Those were in the 50s, maybe the 60s. I think it's somewhere in the 60s. We thought these robots were just around the corner, and we still don't have that kind of robot. And now we have the ideas of the battle droid down at the bottom, which really we still don't have. All those drones and things that we do have, they cannot tell the difference between friend or foe still, whereas apparently these battle droids could. We assume, in Star Wars. And then if you go down to the bottom left there, of course, there's Data from Star Trek, The Next Generation. And that's one of my favorite examples to use of this kind of AI that really, they argued in one of the episodes, right, that he has sentience, that he is a feeling being, as opposed to just a robot. Not only can he do all the calculations, and of course, all of these can perceive, and that is the thing that is actually stopping us from the two on the top and the one on the right. The project that he gives you in the book is this kind of navigating through space, and it's the idea to think about that is how what we need to give it is not just the cognition and the system to be able to think about things, but the perception of the world. And it helps to have the kind of visual world, but it depends on the animal, as animals do this. And sometimes they use very different senses, right, to navigate through the world and to avoid obstacles or to find their food and so forth. But it's really the perception. And in fact, it used to be that one of the cars they built that could drive on its own without anybody in it had dozens of cameras and several also sonar to tell it what was around it, because it's very difficult for us to get one of these robots or machines to know where basically to move its eyes. So that there's a little tiny structure called the superior colliculus in the midbrain, and it is telling us where to move our eyes based on a lot of information, and that is still really a mystery to scientists of how to figure out how that's working, and then to utilize that information for AI. So why study sensation and perception other than its requirement in the it's one of your course requirements, or it fits something in your course structure? Well, one is the recovery of function. So like this basic research about how we perceive what we're going to talk about can be utilized for things like helping people to hear, even if they have a damaged cochlea or damaged middle ear, those bones, helping someone to see, even if there is damage to some aspects of their eyes, whether that's their optic nerve, or helping someone to move who is in that kind of locked in syndrome, who's unable to move. Maybe they can not move their body, but maybe they can move a machine with their mind. So all that kind of recovery of function. It's important for designing a better environment. Every single semester, I wonder about myself for putting this in quotes. I don't like the overuse of quotes, and yet I always put them back on because it is this. So the top link on that, if you want to click into that. I'm not going to require any of these. We usually do watch in class at www.jnd.org. But that top one, which HFES, I can't remember what the ES stands for, but it's the Human Factors Society. That is, you can be studying perception performance. Some people call it human factors, but that is a very applied kind of perceptual degree that one of my friends got a degree in that, and he has worked with heads-up displays in aircrafts. He has worked with Dell and PeopleSoft, I think it was, that where he's working on helping the programs and the platforms be more usable. He has worked in education, making education more usable for people who have learning differences. And he's now at Google. And so the human factors is really, it's a huge field in and of itself now. And that environment really does include not just the kind of virtual environments, but our real environment as well. So I do kind of like that in quotes. The next one down, the www.jnd.org, that JND stands for just noticeable difference, which we won't talk about it like that, but we will. We'll talk about the difference threshold, which is the same thing. And it's a basic concept in the field of sensation and perception. And I don't know how this, I'm going to space on his name as I'm talking, and I don't want to go look it up. It's Don Norman or something. How he got that. He must have gotten that early and stole that website, because I can't imagine how one single researcher gets a website of www.jnd.org. But this is his website, and I usually have students go down to the bottom and click on how our environment might make us happy. So if that's something you're interested in, you might want to go watch that. And I think that's the title of it, down at the bottom of that first page you click into. He is one of these kind of designers who comes from the field of psychology, and he talks about himself as being this human factors person, like my friends, where it's really about usability, but he's changed to take in these other psychological concepts of this kind of visceral happiness, this kind of reflective, how different parts of our environment influence us on a visceral level, on a reflective level. And so it's really interesting, especially if you are interested in design. So my niece got her degree in graphic design, and she does this kind of feng shui stuff now. So I sent her this, and she thought this was really neat as well. So it's kind of more generalized. And I won't talk much about emotion or how perception affects emotion. And this is one of the places usually where I say, well, at least I say it one time. And again, that is something people could do their projects on if that's what you're interested in. We can use it for pain management. So how we can distract people from pain in various ways. I'm kind of running over, so I'm not going to go into the examples right now I usually go into, but this is one thing we can use it for, is again using that basic research translated into applied research for helping people manage pain. I just talked for a couple screens about robotics and computers, how that might be used. There's inherent interest and appreciation. This is really where I came from, as I took this class as an undergraduate, and I'm one of those people who I lost my vision. I was losing my vision probably as an infant almost. They did not catch it until I was in maybe first or second grade, and I was already legally blind. And they said she's been unable to see for a really long time. So through the years, with my different prescriptions and everything changing, and I spent a lot of time in the car with brothers and sisters that I really didn't want to talk to for 12 hours a day. So I have a lot of kind of internal perceptual games that I play with myself. And when I took this class, it just answered a lot of questions for me about me. So there's this inherent interest in how we perceive the world. And I will go check this link, this cool opticalillusions.com, which used to have some cool optical illusions if you like that kind of thing. And then there's also a greater understanding of your own and others' perceptual experiences. So over the years, understanding my perception of the world has helped me a lot, not just in bringing awareness to my perception and kind of having fun with that, but understanding sort of why I perceive the world the way I do. And it helps me with others as well. So knowing that my mother's sight, what was happening to her when she had cataracts, knowing that my brother's schizophrenic and how he perceives the world differently, that really helps for finding understanding for other people and finding compassion for other people. Okay, I'm going to talk about this perceptual process for a little while here, and there are 7 steps that I'm going to go through that gets us from the stimulus from the environment into some experience and action, some response to that stimulus. And I'm going to start with this. He has a picture of a drawn tree in the book. I stole this picture of the angel tree on John's Island because I think it's beautiful, and I might as well use it. And I want you to keep in mind, and I think there's several times when I go through this kind of idea that knowledge and previous experience are really affecting every step of the process. And maybe I don't explain that or say that often enough. From what even the features of what I see are going to be influenced by my knowledge and my previous experience. So what is the context that I am in, and how am I interpreting where I am based on previous experience? So cognitive processes have an influence on perception. What does this mean? Well, I'm going to talk about bottom-up versus top-down processing for just a little while here. And I have this really not very good slide that I'm not sure helps people, but I created it with the little arrows at one point, and I thought this is great, and I'm not sure how much it actually helps you students, but how I think of it is the bottom up is really, so we're starting, and this is the way perception is talked about in the textbook and in all textbooks. They talk about it as this bottom-up process. Where are we going to start? We're going to start with the eyes, and then we're going to go through the subcortical structures, and then we're going to get to the cortex, and then we're going to get to the frontal lobes where we can make decisions. That's a really bottom-up description of perception. So it starts with it actually doesn't start with the eyes, it starts with the data, the environmental stimulation. That becomes features that make up our objects and basically our concepts of what we're going to see. That becomes some kind of concept, which becomes my decision of what this is, basically. And I'm not sure how to exactly distinguish concept from decision. And you don't need to. This is not the part you really need to remember, have some memory of. I'm just trying to help you understand what bottom up versus top down is. So the concept and decision, you can kind of think of those as the same thing, but they're not. So that I'm deciding what's in front of me right now is a rue plant. And the concept then becomes a rue plant. But see, I'm already going to the top down. So I decide that this is a rue plant. There's a rue plant out there in front of me. That's the kind of concept. And it is made up of features. And if I thought this was a different plant, if I thought this was, I can't think it's lavender because it doesn't look at all like lavender, but if I thought this was some kind of azalea or something, what doesn't completely matter what's out there in the environment, right? If I think it's an azalea, that decision that, hey, I'm in front of my house, I'm at the azaleas, that's going to influence my perceptions, my what's going on in the kind of background thinking of that concept of the features that I see. Rue plants and azaleas actually don't look very much alike, but I just had to pick a bushy plant. And then that can influence the data in the environment. And it actually doesn't influence the data in the environment. It's just that's the direction that the top-down processing goes. But it can influence the features that we see. So we can miss certain features in our environment because we assume that they're there, and we assume something different is there. And oftentimes when I'm in class, I write up that Paris in the springtime, which you've probably seen somewhere before. And when you're reading it, you sometimes don't even see the second the, because we don't expect it to be there, and it's really clear in our reading behavior. We have some expectations that influence our interpretation, but also influence the actual features and the data that we see. I'm going to do this demo about top-down processing, even though it's kind of weird online, and it's just, I'm hoping this works. So I'm going to have men close your eyes and just listen. For now, close your eyes. Women, you want to look at the screen for just a couple seconds. So men, your eyes are closed. Okay, men, open your eyes. Okay, so men, I'm going to have you look at the screen. Women, close your eyes. So just close your eyes for a few seconds here. And men, you're going to have to look at the screen here for a few seconds. I'm going to change it. Now, everyone, open your eyes. Those went really quickly, but I think it's okay. And you're going to name the picture on the following slide. Okay, so I paused for a second for you to kind of see. And so what typically happens here is that a lot of the men, not always all of them, but a lot of the men say, I see a face. And a lot of the women, not all of them, but well, usually all of them actually say, I see a mouse or a rat. Okay, this is an ambiguous picture. It can either be a rat with the little nose in the front, or it can be a face. So this guy kind of looks like he has glasses on and he's leaning back, right? And his nose is the rat's face, if you go back and forth between that ambiguous picture. And what I did was I set up what they call a perceptual set. Okay, so your previous experience and knowledge, women saw a clear, unambiguous mouse rat. You can go back and you can kind of go back and not close your eyes, just go back in the PowerPoints. And men saw a clear, unambiguous face. And so that really influenced how you interpreted this ambiguous picture. And that's just one example of top-down processing on how we're processing the world.